Hello and welcome to yet another video of Cornerstones of Math. Today we are going to calculate the volume of the solid formed by rotating an area enclosed by x equals 0, y equals 1 minus e to the minus x, and y equals 1 minus 1 over e about the y-axis. And the graph basically looks like this. So we have to rotate this area around the y-axis. Here, it is obvious that the simplest method is so-called disk method about the y-axis. That is, we obtain this function in x equals fy form, that is, x as a function of y. Then the area of the cross-section sy at an arbitrary y-coordinate is given as the area of the circle pi, and the radius is fy, which is x, so the area is pi fy squared, or you can write it as pi x squared. And the volume V of the solid of revolution can be obtained by integrating this cross-section, where in this case y changes from 0 to 1 minus 1 over e. And since sy is given as pi x squared, we have pi integral from 0 to 1 minus 1 over e x squared dy. So let's find this x as a function of y. From here, y equals 1 minus e to the minus x. E to the minus x equals 1 minus y. So minus x equals ln 1 minus y. So we have x equals minus ln 1 minus y. Therefore, v is given as pi integral ln 1 minus y squared dy. Now we have to integrate this function. This function is actually a bit complex, majorly due to this ln 1 minus y part. So let's use substitution to simplify the given integral a little bit. Let t as ln 1 minus y. Then 1 minus y equals e to the t. So y equals 1 minus e to the t, which also gives dy equals minus e to the t dt. So we have pi integral t squared minus e to the t dt. Also, when y equals 0, t equals 0, and when y equals 1 minus 1 over e, you can easily find that t equals minus 1. So we have integral from 0 to minus 1, and if we change the interval into from minus 1 to 0, we simply change the sign of the integrand, so we have t squared e to the t dt. And this integral can be easily done using integration by parts. So here, let t squared as u and e to the t as v prime. Then u prime is 2t and v is e to the t. So we have pi uv, so t squared e to the t, minus 1 and 0, minus integral u prime v, so 2t e to the t dt. And if you calculate this part, it simply gives minus 1 over e, and we have minus 2 integral t e to the t dt. Here we use the integration by parts again, this time with u equals t and v prime equals e to the t. Then u prime is simply 1 and v is e to the t. So we have uv, so t e to the t, minus integral u prime v, so 1 times e to the t, so it's simply e to the t dt. So we have this part gives 1 over e, and if we integrate e to the t, we simply obtain e to the t. So we have e to the t minus 1, 0, minus. So we have, now this part is 1 minus 1 over e. So we have pi times minus 1 over e minus 2, and this part is 2 over e minus 1. So we have pi minus 1 over e minus 4 over e plus 2, which is 2 minus 5 over e pi. So this is the volume of the solid of revolution. And that's all for today's video. If you enjoyed this video, please hit that like and subscribe buttons, and also please go check my other videos, and as always, I will see you in another video.